Hello all. In this video we are going to talk about the four types of built-in data: list, tuples, dictionaries, and sets that I briefly mentioned about them in my video on variables and constants. So here we're going to talk about them more in details. So these are very close to the arrays, and arrays we have discussed in NumPy videos. Just wanted to tell you a little bit about the differences between arrays and the closest one to it, which is the list. So why would you need something like list or array? So arrays are not built-in data. You have to import them from NumPy. But also, although lists and arrays have very similar properties, they are both ordered. They start from index 0. They are mutable, which means you can change them after you declare them. They can take over non-unique values and so on, but lists can store heterogeneous data, while arrays can only store one kind of data, so like just numbers, just letters or strings. But as I said, lists are similar to what we had in MATLAB called cell arrays, and we can store, as you can see here, all sorts of different data: integer, float, string, boolean, and everything can be stored under the same umbrella. And for that reason, lists are not really appropriate for mathematical operations. So you cannot get a norm of this vector. If I define a matrix with booleans and strings, you cannot get inverse of that or determinant of that or so. But arrays, since they typically store numbers, unless they are string arrays, then they are really appropriate for math operations, and they are more efficient in storage of data as well. That's why we say NumPy is very efficient and optimized for mathematical handling. So just wanted to let you know what is the difference between arrays and lists and why would you need list. The main advantage is saving heterogeneous data under the same name. Now here I mentioned ordered several times. Let me clarify what exactly I mean by orders, because ordered and index are not exactly the same thing, although ordered kind of basically implies index. But let me tell you exactly what I mean. So here I have this string, and it has lowercase letters from A to G followed by uppercase letters from A to G, and then I'm gonna do typecasting here. I type it as, I convert it to string, but it is already string. So here it's not doing really anything. Then I cast it to list, I cast it to tuples and sets, and then I show you the results of that, okay, and see what happens. So let's go ahead and run this. And here you can see that when I save it as a string, of course, it's the same as the original one. When I save it as list, as you can see, the order, so it kind of separates them into characters, but the order is preserved, right? So you see I have all this lowercase letters followed by what? Uppercase letters. The same for tuple. So tuple is also ordered like list. The order is preserved, but if you look at sets, you see the order is not there anymore. It seems like these lists or tuples are kind of shuffled and the order is random. So for a set, the only thing that matters is that character, that number is in the set. Where in the set, it does not matter. So we say sets, and of course later we'll see dictionaries, they are not really ordered. Now I saw something says dictionaries are ordered as of Python 3.7, but I tested on mine and it wasn't. So although I guess mine is more recent than that, my version of Python, but I did not see that order here. So let's go ahead and start talking about lists. So lists, as I said, they are ordered. They have index. The first one, just like arrays, start at index 0. They are mutable, which means you can change them later. Their sizes are dynamic, so you can change the sizes, remove something, add something. The data does not need to be homogeneous. They can contain duplicate values, and the only thing that matters is their position. So as you can see here, when I declare this list, I have a 3 here and I have a 3 here, but this is index 1 and this is basically index 4 here, right? So there is a difference between them, although their values are the same, but their locations or positions are not. And the way that you declare a list is just like arrays, you declare them with brackets, okay? So here, when I declare this list, and then I say, hey, give me index 0, well, it should give me 1. Give me index -1, it should give me the last one. Give me -2, it should give me the second to last. So the negative indices are also available just like arrays, and you can see them here, right? This is 1, the last one is true, the last one is high. So negative indices also are applicable. Then I can use the command append, which adds the number that you're asking to the end of the list. So look, my list was this. Now I'm appending a 6, and 6 should go right after true, and you see that it is. Right? I can simply print the whole list and see the result, right? So you see the 6 is added at the end. That's the append command. Or if I don't want to add it at the end, I want to add it at the specific location, I use the insert command. So say go to index 2, which is the third entry, and add a 6. So compare this one against this one, and you see that in the third position, which is right after 3, now a 6 is added. That's because of the insert command. I can say remove. If I say remove, what does it do? It goes ahead and it removes the first occurrence of the value. So the first place that you see 6, which is in this guy, the first place you see 6, which is this one we just inserted, get rid of it. And you see it did, right? So that's the remove command. You can also use the pop command. If you don't pass a number to the pop, it will pop the last number. It will remove the last number. So look here, I did the pop on this, and then the last number, which is 6, is gone. But if you pass to it a number, here means go ahead and get rid of entry 2, which is the index 2, which is entry 3. And if you compare this one against this one, right, look at these two, you see that this number -5, which was in position 3 or index 2, is gone. So you see the size of a list is dynamic. You can add, you can remove, you can insert, you can pop, and all sorts of things. And if you use the method .clear, then it will clean up everything. So you get what? You get an empty list, right? Then what else do we have? Here we have a new list that I defined, and then I can use the sort command, and it will sort it for me by an ascending order. So you see, this is the original one here. This is the original one, I'm sorry, this is the original one, and then this is that one sorted in ascending order from -5, which is the smallest, to pi, which is the largest. And unlike arrays that there was no method for sorting in descending order, in list there is a method, so you need to pass to the sort as an input, say reverse true. Then it will sort it in a descending order, as you can see over here. In arrays, remember, we get something and then we did something like vector and then column -1 to reverse the ascending order and make it descending. But here we have an explicit entry into the sort command. And this one, by the way, there is an equivalent for that. There is an equivalent command for that in the list, and that is called mylist.reverse. So with .reverse, you can clearly reverse what? Reverse this list. So look at this guy, and this is the reverse of that, as you can see. Right? The order is backwards. And you can, of course, access a part of the list. You can slice it, what we call. So here, I'm accessing what? From index 0 to what? Not 2, remember? The column operator goes to the last number -1. So I'm only accessing 0 and 1, which is the first 2 entries, which is these two, as you can see, right? And another important thing is this. Take a look here. So this one is this reversed one, the first 2 entries, not the original one. What does that mean? It means when you did this reverse, it alters the original one, okay? So now your list is not this original one anymore. When you apply the reverse, your list is this guy now. So when you say give me entries 0 and 1, index 0 and 1, that's what you get. When you say give me 1 column and no second number, that means all the way to the end. So you get from entry number index 1 or entry 2 all the way to the end. So you will get this part, as you can see. And then if you say don't provide the initial number, say all the way to 3, means from the beginning to entry 3 minus 1, which is 2. So you should get 0, 1, and 2, which are the first 3 entries, as you clearly can see here. Okay, so you see, list has all sorts of methods for adding, removing entries, accessing, sorting, and so on, but nothing mathematical. And of course, you cannot do mathematical on a heterogeneous data like this. So this is a list. The next one is a tuple, and tuples are like the constants of this word. Basically, they are immutable. They are something that when you declare them, you cannot change them anymore. You declare them by parentheses, and you can pass to it heterogeneous data, right? They are ordered, as you can see, but as I said, they are immutable. And here, to check that, we are trying it using the try and accept structure that we'll see in one of my future lectures. So basically, I created this tuple with 3 entries, and then I'm trying to change this entry number 1. So here, by the way, index 0 is the first one. So index 1 is Mike. I'm trying to change it to Jim. If I just go ahead and issue this command, I will get an error and say, hey, tuple cannot change. But if I pass it to try and accept, if this one doesn't run and it leads to an error message, then the accept part will run and it shows you that, hey, tuples are immutable, and this is exactly see what happened. So only this part ran because this top part cannot be running, and it will lead to an error for you. And here, just in case you don't believe me, let me go ahead and show it to you. So here I just run that single line of code, and you'll see that I will get an error and say, hey, tuples, they do not support item assignment. So you cannot do this. Once the declaration is done and the assignment is done, you cannot reassign them. Okay, so they are acting like constant. So if you want to keep something constant and not allowing the user to change it, you would define it as a tuple and use parentheses for that. What is a dictionary? A dictionary is like a pair of data. Unlike these other ones, unlike lists, unlike tuple, and the set that we'll see later, here you don't have individual numbers, you have a pair of numbers where the first number is called the key and then column, and the second number is called value. So you have a pair of key and value. And why do we call it a dictionary? Because in a dictionary, when I go, what do I have? So when I search a word in a dictionary, what do I say? I go ahead and find, for example, immutable, and then it says cannot be changed, right? So you see, this word acts as a key for me in the dictionary to find this value, which is what? Your definition. So that's the same thing. These numbers are acting like a key for me, and then the value for them, which is this name, is the value that I'm trying to search. So for example, what could these numbers be in real world? They could be, for example, your employee ID number or your student ID number, right? So if I just want to find somebody's name, if I know their student ID number or employee ID number, then I can easily find what? They can find their names or some other type of information that I call the value. So that's why we call it a dictionary. And when you define a dictionary, you use braces as well as sets that we're going to see later, both of them, because they are unordered. So this unordered stuff you define with braces. And you can print the whole dictionary if you want, right? And it is going to show you the whole thing, as you can see. And then the thing is, they are not ordered. So I cannot say, hey, this set of data, this pair of data is index 0, this pair of data is index 1, this is index 2. So look here, if I say, give me dictionary index 1, which is this guy here, right? Give me that one, right? So see what happens here if you order that command. You see, you get an error. Say, hey, what are you talking about? Dictionaries are unordered. You see that here? So dictionaries, they don't have order. So this is not location 0, this is not location 1, this is not location 2. So keep that in mind. There is no order for dictionaries. Another way you can show a dictionary is to use a for loop and say for key and value in the dictionary dot items. This is a method that you can use with the dictionary. For key and value in dictionary dot items, print the key and value, and if you do that, it is, instead of showing it in one piece, it is going to show it in pairs. So instead of showing it this way, it is going to show it in pairs like this. Okay? So you see, I'm not using any number. I'm not saying dictionary from 0 to 2 or something. I say dictionary dot items and key and value in it. So I'm using in range for loop, which we're going to see later. Now, here I can, as I said, I can pass the number and I can get the value. So I say, hey, what is the value for key of 30? Give me the value. And you see here it says what? Jim. So if I know Jim's ID number, then I can find the name for that person. I cannot do the other way. I cannot say, hey, give me the key for the name Mehran and I expect it to return to me 50. So I can have the key and get the value, not the other way around. I cannot pass value and get the key. Look here, you are going to get an error here, as you can see. Okay? The other thing we have to keep in mind about the dictionaries is keys have to be unique, but values do not need to be unique. So here, I have to have 30, 40, 50. I cannot have another 30 here. If I have another 30 and call that Jim and then 30 again Joe, what do you think would happen? So I have two similar keys, two different values, right? Let's see what happens here. You see what happened? So the first one is kind of eliminated. There is no Jim anymore. There is only Joe and Mehran. Why? Because it seems like for the key of 30, I have redefined the value from Jim to Joe. So this first one is going to be overwritten. That's why we say keys have to be what? Unique. But now if I go ahead and say 40 and then change this to Jim as well, right? So now I have different keys, but non-unique values. Look, no worries, right? You see, I have two people with name Jim that have different IDs. And of course, that's very common, but I cannot have two people that have the same ID. That's a mistake. So that's why you always have to have unique keys in a dictionary. So we learned something about dictionaries. We learned that we can get the values from the keys, not the other way. There is no order for them. The keys have to be unique, not the values. We can redefine the dictionary stuff, right? Their values after. So at 40, instead of Jim, I can say, hey, go ahead and make it George and print it again. And you see now, instead of your original, let me change back this to some other name, right? So the name that we had was Joe and Jim, right? So the second one was Joe. Let me run it one more time. So here, this is what I have originally, but now I said at key of 40, go ahead and change the name to George. It does. And so you see clearly I can do that, and it means that dictionaries are what? Dictionaries are mutable. Of course they are. You can change them. Now I can remove a pair. I say, hey, go to the ID 40 and pop it out. So if I do that, you see now it was this, now it's this one. So it went to the ID 40 and got it out of the list. I don't even need to know who that person was. Say, just get rid of it. And it did. I can add a new person. Hey, now assign that ID 40 that I removed because that person left the company, right? So that person, Joe, left the company. Now a new person came called Mike. And I want to reassign that key of 40, that ID of 40 to him so I can add something to the dictionary later and say, hey, go ahead and add Mike with ID of 40, and you see now it does, right? The other thing I can do, I can filter out the dictionary. So for example, say, hey, give me all the names that their IDs are 30 and 40 and assign it to a new dictionary and print it for me. So it goes and search the list and only brings out those people with IDs of 30 and 40, right? And then it gives it to me. How do I do that? I define a new dictionary. You see, I'm using braces, and I set keys, column, dictionary key, right? So how do I form this dictionary pairs? The first number is key, the second number is the value at the key. And where does the key come from? They are coming for key in keys. So for any value in this array keys, go ahead and get them one by one, place them here, and then add as the part of the pair the value at that key. So it should give me only what? This portion, and you see it does. But remember that I changed the one of the names to Mike, and it does that. Okay? So you see, I can filter out. I'm only interested to see those people with IDs of 30 and 40, so it can filter out the dictionary for me. The other thing, the last thing I want to emphasize is, look, when I added this Mike with ID of 40, it did not add it to the second place where this second person was removed. It added it to what? To the third place. So the keys are not in any ascending order or anything, okay? They are not sorted. This dictionary is not sorted. And when you add something, it automatically will be added to what? To the end of your dictionary. But again, there is no end, there is no beginning in a dictionary. There is no order. So whether this Mike is in the first place, middle place, end place, it does not matter. The only thing that matters is this pair exists in my dictionary. Where, it does not matter, because dictionaries are unordered here. But I'm just trying to tell you exactly how it does it. The last part is sets. Sets, also defined by braces. They are unordered. The location does not matter. They are mutable, so you can put in them any value afterwards and change them and resize them and so on. The important thing is they cannot have duplicated elements. Remember, dictionaries can have duplicated values, no duplicated keys. Sets cannot have. They are not like lists. You cannot have 2 2s or 2 4s or 2 5s. Everything is unique. And what is the major advantage of using a set as opposed to a list? Sets are very, very optimized to check whether something is in them or not, and I'll show you how to find whether an element is in a set or not. So here I define 2 sets of numbers, and then what are some operations I can do with a set? So here is whether I check something is in it or not. I say if 5 in set 1, then go ahead and print it. You see how simple it is? If 5 in set 1, as simple as that. If 4 is in set 1, then print it that it is. Then I say 5, not 1. 5 is in set 1. Look here. So as simple as that. If in, that's all it is. You see, it says 5 is in set 1. But if I say what? If negative 5 is in it, go ahead and say that. Well, of course, negative 5 is not in the set, so I'm not going to get anything out of this, right? I can add else, for example. I say what? Else, right? And then what? I add this, and then I can go ahead and say this negative 5 is not in the set, right? So let me do that. Is not in the set. So let's go ahead and do that one. You see, it says negative 5 is not in the set because, of course, it was not. So if number in set, as simple as that. What are other things we can do? As I said, it's you can change it. You can add and remove stuff to it. So look here. I'm going to add a 6 to set 2, and then I'm going to add a 5 to set 2, and I'm going to show you the result. And look, the numbers were what? 3, negative 1, and 2, right? There were 3, negative 1, and 2. And then I added a 6 and I added a 5, both to set 2, and then I'm printing set 1 and set 2, right? So this is set 1 now. Set 2, you see, 5 and 6 are added. but clearly the order is not the original order anymore, right? 3 is not in the beginning, 2 is not at the end, 5 and 6 are not at the end. So when you add stuff, the order is not preserved because there is no order for a set. And some of the beautiful things I can do with sets, just like the math classes that you have, I can do intersection using AND operation, I can do union using OR operation, or I can do subtraction using negative. And you see here, the elements common to both of these are 2 and 5. The union, which is everything that is unique added together, is this whole set, and subtraction is everything in set 1 but not in set 2. So basically is set 1 minus the intersection of them. So get 2 and 5 out of set 1 and you get 1, 4, and 7. So you can do all of the math operations you learn for sets in math classes. You can do it using a set. So hopefully this video was useful to you, and I will see you in my next lecture. Thank you.